You should have already, before you watch this, you should have already watched the Chapter 3 integrity video where I introduce Chapter 3 and I essentially have my recorded lecture of it. The purpose of this video is for you to do some practice problems. So it's not for you to learn from scratch here, but to have already looked at the integrity lecture and now to do some practice. So I'm going to start off here with number 3.2, which says, indicate which subatomic particle, proton, neutron, or electron correctly matches each of the following phrases. More than one particle can be used as an answer. So in A, it says is not found in the nucleus. So not found in the nucleus. And remember, we have to choose from here proton, neutron, and electron. And this is number 3.2 of the end of chapter exercises. So not found in the nucleus would be the electron, right? Because the nucleus contains protons and neutrons. B says has a positive charge. Well, that would be a proton. Positive charge on the proton. Neutrons are neutral, and electrons have a negative charge. C says can be called a nucleon. Well, nucleon is just another word for things that are in the nucleus. And D says has a relative mass of 1,837 if the relative mass of an electron is 1. And that's either the proton or the neutron. I would have to look it up. But the basic idea here that the textbook's trying to get at is that protons and neutrons are very heavy compared to electrons. So take that away from number 2 there. Okay, here we go with number 3.4. Now, if I was in your shoes, to really make this effective, I would stop the video right now, and I would do problem 3.4, and then once you've thought about it and you've looked around in the textbook to find how to do it, then come back and watch the solution. So 3.4 says, indicate whether each of the following statements about the nucleus of an atom is true or false. So remember, the nucleus is the collection of neutrons and protons that are in the center of the atom, and then I have electrons in kind of a smear around the outside. So these are my electrons. They're kind of messy. So 3.4, we're looking to see whether these statements are true or false. The nucleus of an atom contains all of the heavy subatomic particles. That's true. We know that protons and neutrons weigh a lot more than an electron. So pretty much all the mass of the atom is in the nucleus. B says the nucleus of an atom accounts for almost all of the volume of the atom. That's false. As you can see from our picture here, most of the volume is coming from my electrons. The nucleus is actually only a very small amount of volume. C says the nucleus of an atom has an extremely low density compared to that of the atom as a whole. Well, again, that's false because our nucleus is this really dense collection of neutrons and protons, and the fluffy electrons are surrounding it, and they take a lot more space. D says the nucleus of an atom can be positively or negatively charged depending on the identity of the atom. And that's definitely false, because when we look at just the nucleus, it only has, here's my nucleus. What does it have in it? Well, it only has neutrons, which don't have any charge, and protons, which have a positive charge. So nucleuses, nuclei, that would be the correct way to say that, are always positively charged. They're always positive. Okay, that was 3.4. 3.6 says determine the atomic number and mass number for atoms with the following subatomic makeup. So remember here, 3.6, stop, do the problem, come back. So atomic number is equal to the number of protons. And mass number is equal to the number of protons plus neutrons. So we want to know the atomic number of each of these and the mass number of each of these. So in A, if it has one proton, one neutron, and one electron, its atomic number equals 1, because that's the number of protons I have. its mass number equals the number of protons plus the neutron, so that would be 1 proton plus 1 neutron, so the mass number is 2. In B, we have 10 protons, 12 neutrons, and 10 electrons. So my atomic number equals 10, and my mass number equals my number of protons again, which was 10. That's why that was the atomic number, and my number of neutrons added to it. So 10 plus 12 gives me 22. And since C and D are pretty much along the same lines, I'll let you look at those some more. 3.8. So pause. I'm going to go on to my next slide here. Do 3.8 and then come back. So 3.8. Determine the number of protons, neutrons, and electrons present in atoms with the following characteristics. So we want to know protons, neutrons, and electrons. And in A, we have an atomic number of 10 and a mass number of 20. So, number of protons will equal the atomic number. So, I have 10 protons. My mass number, my number of neutrons will be my mass number minus my protons. So mass number minus protons. Let's make sure I have those numbers right. And I don't. Yes, I do. Which number am I on? Mass number is 20. Phew, good. So we have 10 neutrons. All right, and then it asks for electrons. Now, this is a neutral atom. And because it's a neutral atom, I can say that the number of electrons is equal to the number of protons. So my number of electrons will equal 10 as well. All right, let's do B. B, I have a mass number of 110 and a Z of 48. Now Z is just the same as the atomic number, so don't let that fool you. And it tells me that's 48. So that must also be my number of protons. My mass number is 110. So my number of neutrons will be my mass number minus the protons. So let's see, that's going to be 110 minus 48. What is that, 52? 52 neutrons. Now, electrons, again, neutral atom, so this will equal my number of protons. This is only true for a neutral atom. If I have an atom with a charge on it, which is actually called an ion, then this isn't true. So that means I have 48 electrons. Okay. I'm thinking I'm only going to do A and B here of each of these, or maybe only even A as I look at all the problems that we have. And I know you probably don't want to be listening to me talk for hours on end. So let's go on and do 3.10. And go ahead and stop the video, do 3.10, and then start it up again. And I'm going to draw this in while you do that. A symbol, atomic number, mass number, number of protons, number of neutrons. And I filled in the first one for you. Let's keep it interesting and do, well, let's actually do all of these. Because this is a kind of common way that you would find these questions asked. Okay, so first off I have 28, 60, 18. This is where we would play interesting music if I can. if I was musical, which I'm not really. Okay, then down here, 235U and 92. All right, so let's start here at the top. If my atomic number is, let's use a different color. If my atomic number is 28, then my number of protons must also be 28. My number of neutrons must be then my mass number minus my number of protons, and that's going to be 32. The symbol then, you have to get out your periodic table here. So my symbol, I need to find the atomic number is 28. So I need to find element number 28, and that is nickel. So there's nickel, and I need the mass number and the atomic number. So I've got the mass number up here and the atomic number down there. Okay, let's do the next one. I have an atomic number of 18, so I can automatically fill in my protons. My number of neutrons plus my number of protons, so 18 plus 17 would be my mass number. And what is that, 35? You can tell I don't have a calculator right now. 35. And again, going to the periodic table, I'm going to take my atomic number, which is 18, and find what element that is, which is argon. Pop argon down in there. Atomic number goes down there. Mass number goes up there. Next one. Number of protons is 38. The atomic number must also be 38. My mass number is 90, so 90 minus 38, 52. Yeah, 52. And if I got that wrong, you can tell me about it later. I need my element symbol, so that's element 38. 38 is strontium. There's strontium. 90 goes up here, and 38 goes down there, because it's mass number over atomic number, which is opposite what you see on the periodic table, and don't ask me why they did that. They just did. So now I have to take the opposite. There's my element symbol. I've got the atomic number right there. I've got the mass number right there. My number of protons will be the same as my atomic number. And my neutrons will be 235 minus 92. And that's going to be 143. We'll go with that. 143. Okay? That was number 10. All right, let's look at number 12. What information about the subatomic particles present in an atom is obtained from each of the following? Atomic number, number of protons, mass number. That would be the number of protons and the number of neutrons. Letter C, the mass number minus the atomic number. What's that? That's the number of neutrons. And D, the mass number plus the atomic number. Wait, I have no idea what they're trying to get at. Oh, that's the total number of subatomic particles, because you're using the atomic number to represent the number of electrons. All right, number 14. Determining the following information for an atom whose complete chemical symbol is phosphorus. Oops, let's go back to black. Let me erase. Ooh, get rid of that. Black. Phosphorus. And we have 3115. And the question says, what's the atomic number? Well, atomic number is written down here. There's the atomic number. And then it says, what's the mass number? Mass number is written up here. There's the mass number. And then it says the number of protons present. Well, that's equal to the atomic number, so that also equals the number of protons. And the number of electrons present, because this is a neutral atom, this also equals the number of electrons. Neutral atom. That's why that works. Okay, so 15 protons, 15 electrons, a mass number of 31. That was 14. 16 says, using the information inside the front cover, identify the element X based on the given complete chemical symbol for X. All right, take a moment and do that. I'm going to do A and B. So we have X 16.8, that's A. And for B, we have X 19.9. So, key information here. This number right here, It's the atomic number. Tells me number of protons and tells me who I'm talking about on the periodic table. So element number 8 is oxygen. This is oxygen. Notice to identify the element, I never looked at the mass number because we know from our lecture in chapter 3 that mass numbers change depending on what kind of an isotope you have. So only the number of protons identify the type of element. In B, we're looking at element number 9. Number 9 is fluorine. Okay, number 18. Arrange the following atoms in the orders specified. So we have carbon. We have carbon, 14,6. We have oxygen, 17,8. Nitrogen, 13,7. And fluorine, 19,9. Increasing, A says order of decreasing atomic number. So that would be these numbers here. So it would be fluorine, then oxygen, then nitrogen, then carbon. That's A. For B, order of increasing mass number, well, that's this number up here. So we start with the smallest, which would be nitrogen, then carbon, then oxygen, then fluorine. Letter C is order of decreasing number of neutrons. All right, so neutrons is the difference between the mass number and the atomic number. So this guy has 10 neutrons, and this one has 6 neutrons, and this one has 9 neutrons. And was that 14 for carbon? Yes, so this one has 8 neutrons. So decreasing number of neutrons, so we would start with the one with the largest, so we go fluorine, oxygen, carbon, nitrogen. And then for D, increasing number of nucleons, so this is now total subatomic particles. So we have essentially 19 plus 9 plus 9 for fluorine, and 13 plus 7 plus 7 for nitrogen, and 17 plus 8 plus 8 for oxygen, and 14 plus 6 plus 6 for carbon. So this is 19 plus 18. What is that, 37? 37. And 27. And 17 plus 16, that's going to be 17 plus 16, 33. And 26. So increasing number of nucleons, we'd start with our smallest, so that would be 14, that was carbon, and then we had nitrogen, and then oxygen, and then fluorine. Okay, that was 18. 20 says determine the following information for an atom whose complete chemical symbol is chlorine 3717. Chlorine 3717. Total number of subatomic particles present, that's going to be 37 plus 17 plus 17. That's going to be 1, 2, 5, 71. Total number of subatomic particles present in the nucleus of the atom, that's just the mass number. So this was A. B is 37. C is the total number of nucleons present. Again, just the mass number, 37. And then D, the total charge, including sign, associated with the nucleus of the atom. Now we're getting at the fact that there's positive things in the nucleus and neutral things in the nucleus. And so the positive things are what we're interested in when we're calculating charge. So this would be 17 plus. That was 20. Number 22. Characterize each of the following pairs of atoms as containing 1, the same number of neutrons, 2, the same number of protons, 3, the same number of nucleons, or 4, the same total number of subatomic particles. So 22. And in A, we have 40, 18 argon, and calcium, 40, 20. So the question is, do these things have the same number of neutrons? Well, this one has 40 minus 18, which will be 22 neutrons. And this one has 40 minus 20 neutrons, which will be 20. So clearly that's not, they don't have the same number of neutrons. Same number of protons? Nope, because they're not the same element. And they don't have the same atomic number. The same number of nucleons. Nucleons, they both have the same mass number. So indeed, they do have the same number of nucleons. And then same total number of subatomic particles. That's going to be a no because they don't have the same number of electrons, because they also don't have the same number of protons. All right, let's go on to the next question. So at this point, we're entering into section 3.3, and I am going to focus on the questions that are a little more difficult in this section rather than doing every even one. So let's look at number 26. Let's look at 26. 28b, let's do 34. And that'll be good, I think, for this section. And then I'll stop the video and make a different one for the next couple of problems so that you're not watching this forever and ever. Okay, so take a moment, do 26, 28b, and 34. And then come back and start the video again. So 26 says, the following are selected properties of the most abundant isotope of a particular element. Which of these properties would also be the same for the second most abundant isotope of the element? So hopefully when you answered this, you reviewed what an isotope is. So an isotope has the same number of protons, but different numbers of neutrons. So we might talk about this in terms of like carbon. So carbon has the same number of protons because that's what defines it as carbon. But we might have carbon 12 with a mass number of 12, and we might have carbon 13 with a mass number of 13, and we can see that this has 7 neutrons, and this has 6 neutrons. And so these are isotopes of one another. Same type of element, different number of neutrons. Okay, so let's go back and see what the question says. We're trying to decide whether these properties would be the same for the second most abundant isotope of the element as for the first. So let's just use carbon 12 and carbon 13 here as our example. Oh no, I guess we can't because they're going to tell us what the atomic number is. So in A, it says the atomic number is 31. So atomic number equals 31. So we know that isotopes, they have the same number of protons. So this would be, the atomic number would be the same for isotope number 1 and isotope number 2. So that's the same. B says, does not react with the element gold. So from our chapter 1 information, we should recognize that that's a chemical property. And chemical properties are dependent on the identity of the substance. And the identity of the substance is dependent on the number of protons. So these two isotopes have the same number of protons, so they have the same chemical properties. So this would also be the same between the two isotopes. C says 40 neutrons are present. Now, there's where we're getting into something that's different, because the definition of an isotope is they don't have the same number of neutrons. So this is not the same between the two isotopes. Then in D, the density is 1.03 grams per milliliter. And this one's kind of tricky. But let's think about it this way. if I have an isotope that weighs 22 and another atom of that isotope, and then, so we can think about that as they're taking up some kind of total volume. There's my volume. Versus if I had an isotope with a mass of, oh, I need to erase. Oh, except now it's going to erase the entire thing. Let's redraw. Whoops. Oy. Helps if I get the, whoa! Why do you not like me? There we go. If I have similar atoms, but now their mass numbers are, let's say, 26, right? Same volume, but different mass. So this one would have a big mass of 26 times 3 over whatever my volume is. And this one would have a mass of 22 times 3 over the same volume. So that would mean that my element that has more mass would end up giving me a greater density. So the density of two different isotopes is not the same. So this is not the same. Okay, so that was 26. Now we're going to do 28b. 28b, calculate the atomic mass of each of the following elements using the given data for the percentage abundance and mass of each isotope. So you can look up the example in the textbook. You can look up the example I did on the integrity lecture. But basically what we're doing here is taking our percent abundances. Oops, except I wrote the wrong abundance. And we are dividing them. Ooh, ignore that. 92.21 divided by 100%. And I'm multiplying by 27.98 AMU. I'm adding to my second. Oh boy, I have 3 here. So 4.70% divided by 100%. 28.98 plus, oh, stop telling me things, plus, and then I'm just going to come down here because I have no space, 3.09% divided by 100% times my 29.97 AMU. And if I add all of those together, which I'm essentially multiplying my percent abundances by the atomic mass of each isotope, that gives me the average atomic mass. All right, and I need to find a calculator. Handily, I have one. So that's going to be 0.9221 times 27.98 plus 0.047 times 28.98 plus 0.0309 times 29.97. I get 28.08. Actually, it should be 28.09. Gotta watch my sig figs there. AMU. There's my answer. Seems to me like maybe that may have been the one I did on the integrity video, but maybe not. Okay, now let's look at number 34. Number 34 says, indicate whether each of the following statements about magnesium isotopes is true or false. And first it says magnesium 24, so Mg24, has one more proton than magnesium 25. Okay. Hopefully at this point we've figured out that isotopes have the same number of protons and different numbers of neutrons. And even if we forgot, we would notice that their atomic numbers are the same. Whoop, right there, atomic number, both the same thing. So that's false. B says, consider the same two isotopes containing the same number of subatomic particles. Well, clearly that's not going to work either because I don't have the same number of protons or the same number of electrons for my neutral atom. C says 24 magnesium has one less neutron than 25 magnesium. Now that's looking like a possibility if here I'm comparing this with this, the question's saying this guy has one less neutron than this guy. And that makes sense because look, the mass number is one less. So was that B? No, that's actually C. B was false. C is true. A and B were false. D says 24 magnesium and 25 magnesium have different mass numbers. Again, true. Right? Here's my mass number. Here's my other mass number. They're different. Okay, so I'm going to stop here with this video and make another one for the rest of the things. All right, hope that helped.